Hello, for this video we are looking at biogas production, and this is a way of generating a fuel that can be used for various different things, but using a slightly more environmentally friendly way of producing that fuel. Now the first thing is to produce this biogas we have what we call a biogas generator. So here is one that we've got. This one is actually under the ground and we'll talk about why that is in a moment. But into that biogas generator you can put waste material, and it's any type of waste material that can be used to grow these bacteria. But the kinds of things we're talking about is waste food, waste plants, so that's plants that might have come from the garden or gardening, animal waste, and you can even use human waste, and all of that goes into our biogas generator, and it produces in here a substance that we call slurry. And this is basically all of that waste material being broken down by certain types of bacteria. Now it's important that we keep anaerobic conditions in there, and it's important that it's at a warm temperature. Anaerobic just means without oxygen, so there's no or very little oxygen in there, and the reason why we have that is so that we can grow a certain type of bacteria. So it's the bacteria that grow in anaerobic conditions that produce this biogas, and we say that this is actually anaerobic fermentation. If any oxygen was to get into this generator, that means these anaerobic bacteria couldn't work and they wouldn't produce the biogas. Now in terms of the biogas that's produced, it's usually in this area here, and it's actually a mixture of gases. But once we get the biogas, it's under pressure in this tank. This tank is made so that no air can get in. It's got a very tightly sealed lid, and if no air can get in, and the pressure, that means the pressure can build up, and when we have the biogas produced, it can be automatically pushed out, or the pressure actually allows it to be pushed out so that it can be used. Now the types of gas that we find in biogas are mainly methane, so this is the key one that is the one we want because that's the one that burns. So usually if we're lucky we get anything up to 80% of methane. Carbon dioxide is the next one. This can be anything from 10, 15, maybe 20% or higher of carbon dioxide, but we also have other gases such as water vapor, sometimes a little bit of hydrogen, or another gas called hydrogen sulfide. But the key thing here is that the main constituent of biogas is methane, and this is the one that burns, and because it burns we can use it as a fuel, and we can use it for either cooking, heating, even to generate electricity. The other benefit of our biogas generator is that this substance here in this overflow, once all this has been broken down by the bacteria, actually is often a good fertilizer. So this can actually then be used to fertilize soil to grow more crops. So two benefits there: we can get rid of any waste material, makes it environmentally friendly, often carbon neutral, and also we produce fertilizer as well at the end of it, which can be used to grow more crops or more plants. Now another important or another couple of technical points that are important for growing these bacteria and producing this biogas is we said we have anaerobic conditions, but we also need warmth. We need a temperature of around about 30 degrees centigrade so these bacteria can grow to their optimum level. Now this is not always possible, so in countries where it's a little bit colder the bacteria aren't going to grow, but this biogas generator, as you can see, is under the ground, and that provides some level of insulation. The processes that go on in there are exothermic. They do give out heat, but if we've got it under the ground, that provides a level of insulation, so it helps to keep the temperature at a slightly warmer level so that these bacteria can work in the best way to produce that biogas. Now when we set up one of these biogas generators, we do get a little bit of time before we can actually start generating the methane that we want. And if you look here, we can see initially when we set up the generator and got it going, we can see there's a sharp rise in carbon dioxide levels before it drops. Now this is usually to do with the fact that there's some oxygen actually in here before the whole thing begins. So that oxygen is used up for aerobic respiration, produces carbon dioxide, but once that oxygen runs out, the carbon dioxide levels go lower. They don't go down to zero because we still have carbon dioxide produced, but they go down, and that means that the anaerobic bacteria can then start kicking in because the oxygen is gone, and we then have a higher production of methane. So you might have to look at a graph that looks something like this and be able to explain what's actually going on, or even describe and explain what's going on. So the important things here are that we we have to have anaerobic conditions, we have to have the right temperature, and often we have these individual family-sized biogas generators built under the ground so that these conditions can be kept. Now, this is actually quite a good way of producing a fuel, and it's such a good way that in many countries it has been scaled up to produce much larger quantities of biogas. I think I was just looking in one of the textbooks, and they were talking about one in Texas that uses the waste from about 10,000 cows, which is filled up in these giant fermenters, giant anaerobic fermenters, and it produces much larger amounts of biogas. So this is a growing a way of producing a fuel, simply because it gets rid of all the waste that is produced, or a large amount of waste that is produced, and it also produces obviously this fuel, and it's a much more environmentally friendly way of producing fuel than perhaps using fossil fuels. So those are the key points behind producing biogas through biogas generators. We've got small scale ones that are for families, larger scale ones that might produce energy for more people, but really you need to be aware of the conditions, the kind of gases that are produced, and maybe be able to evaluate how good these things are in terms of providing energy for people.